session going to be talk about the context free and non-context free languages uh, session 2 as a part of the automata theory and computability, that is ATCS 54. So in the previous session we discussed about the decidable languages and undecidable languages. So the continuation of that is a concept. We are going to be discuss the Turing machine model as the first component of this presentation milestones. We followed by we are going to be discuss the represent of Turing machine model. This model, how to describe the how to enumerate with the different dimension which is practiced in the most of the finite automata theory and deterministic finite automata theory, push-down automata theory, and various theories are the supporting to discuss this Turing machine model. So that deterministic Turing machine model, similarly after discussing the representation of the Turing machine, the representation of this Turing machine model through the instantaneous descriptions, description. After exercising some transition, so the machine will move to the next state, and produce some outputs. That is, so that is by instantaneous description we can going to be represents this Turing machine model. The other way we can represent those through the transition diagram or transition graph. So this most of the time we have discussed about the state diagrams to represent the model, that is a deterministic finite model or a finite model, the finite automata model. Similarly, the Turing machine model we can represent through the transition diagram or transition graph also. The representation by transition table also, the one effort made by most of the literature is going to be represents the Turing machine model through the transition table, right? So that table have contains the inputs and the number of states which participated. So those will be put it in a row and column across. So then every the cell will going to be occupy some information about the state movement of that the Turing machine model. So these are the presentation milestones going to be follow in this session. More about the machine model and more about this instantaneous description and transition graph and the table. So generally the finite automata that is a language going to be accepted by these regular languages. So going to be A star or A star B star. The star it is a start with a 0 or 1 2. The finite number of values will be going to be accommodated, that is, so that regular language it is accepted by the finite automata concepts. Coming to the discussion about that is the context free languages. So that context free languages, for example, A power n and B power n. So that is n is equal to 0 to n, 0 to some finite quantity. So the example may be string and reverse of string that can be assessed or performed by this non-determinative push-down automata theory. So that is a context free languages. The other way, the improved version or that model which is going to be a complete computer, that is a personal computer or the personal computer in the sense for the general purpose applications. So that is a Turing machine. So that is a power n and B power n and C power n. So that string will be WW. So this can be accepted by the Turing machine. So that finite automata and push-down automata and Turing machine model are going to be accept those languages, or is a general concept going to be discussed and going to be laid down some foundation to discuss this Turing machine theory and continuation. So coming to this Turing machine, so let me say that The formulation is accepted as a model of algorithm or computation. Turing machine is going to be formulate or going to be defect is accepted as a model of algorithm. So that algorithm have computation and it performs some the set with help of set of instructions. It performs some the calculation and it produce some the outcome, consumes the input and produce the output. In the process, it changes the dimension of the input from one state to other state. So at the end, it could be received an product. It is at the end it could be received an output. So that is going to be discussed in the formulation of this Turing machine. The one such a theory called Church-Turing thesis. So Church-Turing thesis it adopted the algorithmic uh, procedure. So adopted the algorithmic procedure carried out by the human beings and computer. So this adopted the theory of the how the human beings practice in their life to perform or solve the problem. So the similar way that Church Turing thesis will be the augmented. It is borrow the concept of that, and similarly computer can carried out by the Turing machine, right? Similarly the computer also carried out the same similar steps which is human beings adopted. So that will be carried out by the Turing machine model. So here we can see that it has been universally accepted by the computer scientist. The entire computer scientist gamut has universally considered this that is a Turing machine provides the ideal theoretical model of the computer. So the computer the classical concept, the classical concept or ideal theoretical concept which is always going to by the emulate by the Turing machines. So that is accepted by the entire world scientific community. So that's why Turing machine is gain the mileage or it come to the light, and the people are going to provide a solution through the Turing machine ideal concept. So coming to this the usage of the Turing machine, especially in automation. So that is the dominant the tool. The Turing machine is the most general model. It is a type 0 language, except the type 0 language used for computing functions. So used for determining the some value through the some functions, so that certain steps will be computed and it will be able to produce some results. It turns out to be mathematical model of a partial recursive functions. So the recursive function which will be provide some solution, so that is going to be boiled down, that is going to be emulate, that is going to be generated with help of the Turing machine model. So having understood this, these are devices for determining the undecidability of certain languages. So we have discussed the decidability and undecidability of the problems. So now that undecidability, certain languages also the find through this Turing machine. So the measuring the space and time complexity of the problem. So measuring the space and time complexity of the problem complexity, the time computation aspects we can enumerate either in the prior analysis or posterior analysis. So I hope you may be all studied in this concept from the analysis of algorithm. So that prior analysis, the most of the scientific community have been practicing. For any problem there is a solution. So what is the cost of that solution? So how much memory will be consumed by the computer? How much time will be taken by the computer? So these computation aspects going to be measured by this model. So that as I told that prior analysis of the computer, the solution by the for the particular problem can be measured through the order, that asymptotic notation. So that is the order of big O, order of the theta. order of omega. So these are all the best, worst, and average space time complexity of the solution for the particular problem. So that which we have studied in detail in most of the algorithmic course, of course. So now the measuring this computation aspects for the particular problem, especially from Turing machine, is the most interesting, and this is important at this junction of time. So now coming to the model, the Turing machine model is as a finite control. Uh, it is pointed with help of the read and head. So read and head, it is a finite control. So this is a pointing the device, which is always point on the particular cell of the tape, right? The tape, it has one tape which is split into number of cells. So there is a tape will be there. So that is a infinite length tape. So that tape will be divided, compartmentalized into number of cells. So each cell going to be accommodated one character, right? So here we have a what is called the tape. We have infinite length of this irregular shapes indicates the infinite length on the either side. So there is a characters are accommodated here, that is A1, A2, A3, A4, so on, and at the right side we can see that blanks are there, so on either side the blank would be possible to occupy, and in the middle there is a number of characters going to be planned to place over the tape according to the problem specified. So that is going to be noticed, that is going to be pointed by the finite control head, that is called read write head. So read write head pointing to the character A3, right? So pointing to the A3 at this side. So this is a infinite length tape, that is. So one tape we have considered now. Each cell can store only one symbol. Each cell can store only one symbol, that is a input or output. So input from the real world and output to the real world, that is a finite state automata are affected by the read write head, which can study one cell at a time, which can study or which can examine one cell at a time. That one cell contains the one character. So to in order to test, in order to observe that character in a cell is a one attempt for the each character. So in one move, that Turing machine tests the present symbol, right? So in one move, the Turing machine tests the presents the symbol under read write head on the tape, and present state of an automation to determine. So on the present state, an automation to determine the the a new symbol to be written on the tape in the cell under the read write head, right? So the new symbol going to be right on the tape with help of the read write head, and motion of the read write head along the tape either moves in left side or right side. The second the activity by this read write head to say the complete mechanism of this Turing machine, the motion of the read write head along the tape either go towards the left side one cell or right side. So thirdly, that the next state of automation also going to be decided whether to halt or not, that is a last state. So a symbol should be inserted and point with the read write head either any direction left or right, and decide the new next state, and we have to decide the termination criteria, that is a halt or should stop after accepting a particular stage. So these are the activities, major activities going to be noticed when we are going to be exercise this or emulate this Turing machine model, right? So coming to this the Turing machine model, that is recursively enumerable languages, or also known as the type 0 languages. right, recursively enumerable languages, and the context sensitive languages and context free languages are also known as type 1 and type 2 languages respectively. That sensitive language is a type 1 and the context free languages are type 2, in this respect they are renaming, that is, or calling with other name. The regular languages RL are also known as the type 3 languages. Type 3 languages, we can say that. So the model, the computing capability of the general purpose computer. So that computer, it has a certain potentiality. So that potentiality will be imbibed to this Turing machine model, which informally can be described as the effective procedure, right? Turing machine model, which is imbibed with certain the behavior or characteristics, especially that is a general purpose computer perform. So those characters will be imbibed by this Turing machine too. The effective procedure, in this way, the finitely describable steps in the algorithm, in the procedure we have defined for the provide a solution for the particular problem. So that will be able to provide with help of the finitely describable, that is a finite number of steps. So that is a certain steps will be noticed, is essential, kind of milestones will be essential to provide a solution for the problem. So those steps are well defined, that should not be ambiguous, that should not be uncertainty. So that should be the crystal clear steps will be essential. So that is a those are the crystal clear, and in the sense that every step is a responsible, every step is going to be contribute to something to transform the input into output. So output may be useful for the real world. Also the input is a raw material, it is entering to that algorithm. So that is a well definedness is essential, and also the steps are discrete. So the clarity will be there. So discrete in nature those steps, mechanical steps of course, that is. So the finitely describable, well defined, discretable, and always terminatable. So that is also most important. The after accepting or rejecting, it has to terminate. It not should be in the loop. It's not should be in the infinite loop. It not should be in the hanging situation. It should be come out from that the with a solution or not solution. So it has to be clarity will be there to finishing that whatever the job is going to be executed by the particular processor. So that is the effectiveness of the processor can be it shows the impact over that the computation. So that computation is going to be follow this effective processor procedure is a quite important aspect, that is. So now the computable functions, a function computable by an effective procedure. So when we call it as when we notify this is a computable function, computable function becomes when it is practices the very impactable effective the principles or some protocols. So those protocols can be expressed through these effective procedures. So these effective procedures are is a clarity, more clear, more finiteness, more crystal clear, more certainty will be there. So these are all adjectives going to be hamper over this effective procedure computations. So this effective procedure going to be invite in a particular algorithm. So that is a computable function. So the function computable by an effective procedure is a more impact, and it will be a more effective one. Having understood this description of the Turing machine capability or potentiality to mimic this general purpose computer for solving the various problems. So that are the effective in the case of what we call it as an the computation aspects. Space could be, memory could be, and the systematic processor of the applying of this the effective processor, and all this is amalgamated to mimic the general purpose computer. Of course, that is going to be simulated with help of this Turing machine model. So deterministic way we can say that the Turing machine model. So that is a earlier Turing machine model we have discussed, that is the tape of infinite length. So that is a two-way. Go towards left side or right side, left side or right side. So they broken into cells. It is splitted into cells. Each component will be one symbol. At what we discussed, the same thing will going to be continue in this concept also. So that is a two-way. That is a read write head will be there, and finite control. The pointer will be there. So that will pointing to always to the particular cell in the tape, which is going to accommodate the particular symbol in the cell. The program containing the position of the read write head, current symbol being scanned, and current state. So the transition will be happening, that is a delta of current state and the current input. So that we have seen in the various dimension of the while we discussing some of the finite automata. So that current state and current input, the current input going to be scanned, it is going to be examined, then it going to be decide to go for the next state with help of this finite control. An input stream is placed on the tape, added to the left right infinitely with the blanks. Read write head is pointing at the left end of the input stage, right? So padding at the left and right infinitely with the blanks, that the blinks are there towards the right side, and read write head is positioned at the left end of the input stream. The single move it depends on the current state and the current input symbol examined. That the current state, moving from current state to next state. The next state may be a terminating state or intermediate state, of course, no matter. But single move will going to be responsible to declare that the current state and current symbol are the quite important the factors to influence to go to the next move or go to the next state. So that is a single move in the Turing machine concept. So that is a change state, the print a symbol over the cell being scanned, change state, and print that display that symbol over the cell being examined. The thirdly, that is a moves, that is a finite control moves it to tape head by one cell left or right. So changing the state, display that character examined, and moves towards the left or right. So these three are going to be happen in a one move, right? These three going to be happen in a one move. That too with respect to the current state and current input, or the vital play a vital role to decide these three outcomes going to be recorded in the Turing machine. Many modifications are possible. So apart from this, there is also the other modification also possible, that is. So coming to the definition, literature wise definition. So we have the 7 tuples, that is a queue, that is what we called finite number of states going to be participate in the state diagram or state graph or transition diagram. So that going to be assessed with help of the or pointing with help of the 7 dimensions. So the first dimension is the queue, that finite number of states could be participate in this diagram, and sigma is the input symbol. Sigma is the input symbol. So that may be 0, 1 or a, B or several some Greek letters, alphanumeric letters can also possible. So the number of inputs going to be welcome to that particular machine. That lambda we have, that is a the tape symbol, that is a safe tape symbol we can address with help of this lambda. And we have delta is of course transitions, the delta of n number of transitions will be there. So that is a q into sigma into lambda, that is a cross product of q sigma and lambda going to be number of finite number of transitions going to be allowed. So that is a flooding the number of transitions. So number of transitions are the number of solutions. So those number of solutions are flooded here. So out of those only few of those transitions are play important role to change of the states, are going to be halt, are going to be stopped after accepting some certain stage. So Q naught is the initial state, B is the tape, the symbol which is the every cell is occupied by either character or blank. So the blank will be the one important aspect going to be placed over the tape. The F is a final state, that is the accepting state, or we can say halting state. So that is going to be play a role in while designing the Turing machine. So that is a Q is a finite set of states. So that lambda is a finite tape alphabets, tape alphabet, that is alphabets related to tape. So that is a B distinguishable blank symbol which is in this lambda, that is the symbol which is present there. And sigma is the input, that is a input from the real world, that in terms of alphabets or alphanumeric, which is a subset of this lambda. So subset of the lambda, that is minus blank we need to be deduct. So Q naught is the infinite or starting state, Q naught is in Q. The F is a set of final state or states which is accepting subset of Q, final state accepting the state, that is Q, that is. So delta is a transition function, or it helps to move to the next, which is a mapping from the Cartesian product, that is what I said, that is q into sigma, that is the sorry, q into tape symbol, that is a lambda, q, the Cartesian product, that is going to be q into lambda into left and right, including left and right. So this is a exhaustive. See, the maximum number of transitions are possible. How many those? Those are the maximum number of transitions are possible. How many those? Those are q into lambda into left and right, that is. So these number of transitions are flooding here, going to be a list here. So out of each, how many transitions are essential for us and how many transitions are productive, how many transitions are able to produce some output. So that is most important. So this is the maximum number of transitions going to be in list. So out of which certain transitions going to be considered here. So those maximum number of transitions we can list with help of this delta function. So that is going to be help or build in a vocabulary of number of states or the states which are going to be enlisted in the particular the deterministic finite automata. Intuitively, the delta of q comma s, that is a what we can say, that q is a correct state and s is a input symbol. Some books they referred s is a input symbol, w is a also input string, various names they are calling. So it specifies the next state symbol to be right and direction of the tape head movement by the model after reading the symbol s while in a state q. So it is currently in the state q and it scanned the symbol s, then it planned to move towards the left or right. That is decided by this finite control or pre-described by this based on the problem. So that is going to be decide the next state. So these are all going to be assert to the polish the the adjectives to be construct the deterministic Turing finite automata, Turing machine model. So we can represent this model through the by employing certain the mechanism. So one such mechanism is called instantaneous descriptions. So that ID, using an ID also you can depict or enumerate the Turing machine model, right? So that is a relation, move relation going to be adopted with help of the instantaneous descriptions. So the one such concept going to be elaborate more about this Turing machine model. That is most of the literatures are going to be practiced. So in order to derive or test the particular strings going to be accept or not accept. So these are all illustrated by the help of the instantaneous description. So this instantaneous descriptions examined and tells about the future steps. For the currently is at this stage and going to be consume certain inputs. After this, which is the next state, right? So that kind of the descriptions, that kind of elaboration going to be narrate with help of this notation, that is a symbol called instantaneous description for the possible move relations going to be adopted in the most of the Turing machine model. The second effort is a transition table. The transition table or the transition table through the matrix, through the matrix kind of table. It is a two-dimensional table going to be follow the number of states going to be participate and the number of inputs including the blank symbol, right? So those are the columns. So columns and number of states going to be the what we call it as the rows, right? So that is a transition table is also one effort to narrate the Turing machine model in most of the practice that the people have been doing. So with the help of the transition table. Then also the final effort is called transition diagram or graph or state diagram, what we said in the previous discussion. So that is a graph is also. These are all portrait the Turing machine. Many action can be used describe that. It is displayed through this the kind of procedure going to be employed to narrate the Turing machine access. So Turing machine access, it will be actively it will display the steps which is left side or right side, which character is and which cell is examined, where it has to stop, and all those the instances are going to be portrayed to this Turing machine actives. The via this portraits are displaying the Turing machine dynamicity to the instantaneous description of the Turing machine. These ideas of the push-down automata in terms of the in terms of the current symbol, So the ideas of that is going to be terms intensive input string to be processed and consider the top symbol on the top of the memory, topmost symbol of the memory. The push-down automata theory, as we know that it will be implied the stack memory. Stack memory is a that is a first in last. So that is the top symbol is going to be considered going to be process the particular input. So that is one concept, that is with help of the instantaneous description we can we can perform with help of this that mechanism. But the input strings to be processed is not sufficiently defined as the ID of a Turing machine. So in terms of the input string need to be processed, so which is not sufficiently defined of the ID of the Turing machine for read write head can move to left as well right, that is right. So an ID of a Turing machine is defined in terms of the entire input strings and the current state. With respect to complete input and the current state, that is going to be define the Turing machine with help of an instruction description, that may be more effective one. So representation by the instruction description going to be further, that is, so we can have that is the infinite length of tape, which is currently pointing Q3 to the character A1, so through the read write head. So we have the all the cells represented by the either character or blanks, right, that we have narrated in the previous discussion. So more towards this representation, we can see the present symbol under the read write head is A1 presently. Currently that the symbol Q3 is going to be at A1. The present state is the Q3, so A1 is the written into of Q3, right. So A1 is written into that is a right towards, that is Q3, and non-blank symbol to the left. Non-blank symbols are towards the left side. There is a non-blank symbols are there of A1, form the string A4, A4, A1, A2, and A1 and A2 and A2. So these are the non-blank characters towards the left side, and at the right side we have that is A4, A2. At the right side we have A4, A2. After that the blank will be there. The sequence of non-blanks symbols to the right of the A1 is a A4, A2, A4, A2. So in instantaneous description we can narrate here the more elaborated in the picture way, that is the left sequence, so A4 to A2 non-blank symbols, and right portion, that is A4 to A4, A2, that is the right sequence. So having noticed these two, and the Q3 at the currently present state, so current state, that is a Q3, and the symbol under examining, that is a A1. A1 is a currently the specimen, it is present on the anvil. So the specimen present on the anvil, which is going to be pointed by the finite control, that is currently at the state Q3, that is a read write head, right. So this representation of this intelligence description for the Turing machine model can have observation. So what observation? For constructing the instantaneous description, insert the current state in the input strings to left of the symbol under read write head. Insert the current state, that is the instruction IDs. Insert the input string to left of the symbol under read write head. Under read write head. So the blank symbol may occur as a part of the left or right. So blank symbol may occur as a part of the left or right substring. So having understood this ID description, so we have the subsequent one is a transition diagram, effort through the transition diagram. So mechanism such as transition diagram mechanism or transition graph mechanism or state diagram mechanism going to be going to be practiced to research the Turing machine model. So having understood this complete Turing machine Turing machine model architecture, so now consider the same situation going to be discussed with help of the transition diagram. So consider the input called B0011B, B0011B. So that going to be input here, that is going to be input here, and after start accepting the string 0, 0, 1, 1, B, when it reaches the blank B, then it is going to be accept and declare that it is a terminate. It is going to be halt, right? It is going to be stop. So initial to final state is coming. So this mechanism is going to be achieved with help of this diagram. Let us assume that machine is in state Qj, that is any state, and the read write head scans 0, that is exam is 0, first 0. So that is a first 0, and we can represent this the tape symbol 0, 1, B, right? The input, that is sigma. Sigma is equal to 0, 1, B. So these are the input symbol from the real world. For especially for this example, 0 comma 1, that of course B is a blank characters. The transition table, there is directed edge from Q1 to Q2. From Q1 to Q2, there is a transition edge. So which is labeled as 0 comma x comma r, right? So 0 comma x comma r. So that is going to be say about the, so the current symbol 0 is replaced by the x. Current symbol 0, this symbol 0, input symbol, going to be replaced by the x and head move towards the right side. Current symbol 0 is replaced by the x and head move towards the right side, right? Head move towards the right side. In other words, so this input B0011B, now it becomes BX011B, right? Because this 0 going to be replaced by the x and move towards the right side. Why it moving root side? There is a still some more characters are there to examine. So that's why it will move towards the right side. How long you move right side? As soon as it reaches the left blank, the rightmost blank is there. Till that point it will move towards the right side. Afterwards it's coming back to the left side. So that is a mechanism going to be practiced. So now after scanning that 0 and 0 will be replaced with the x and tape will move to the finite control read write head will move towards the right side as moving towards the right side, and it may reaches to the state Q2, right? So that is a effort made by this Turing machine model. So that is going to be similarly for similarly for other 0. So the 0 will be replaced fx and it will be coming to left side, and it will be reaches to the final state that Q6. So when it will blank is there, keep the blank as it move towards right side, and it go towards the, if it is a y will be there. So 1 will be replaced by y, 0 will be replaced by x. So if y is there, then it will be blank, come to the Q6, the final state, and it will be terminate, that is accepting, that is a halting situation. This description is going to be fought by the transition diagram. We will solve some more problems. So now to understand this transition diagram concept to represent the Turing machine model, the purpose is going to be illustrated here. The other effort going to be a transition table. So transition table we can have gives the definition of delta in the form of table called transition table. So if delta of q comma a is equal to gamma alpha beta, so delta of q comma a is going to be gamma alpha beta. So write alpha beta gamma under the alpha column and q row, alpha column and q row. So that is the transition table. So we get alpha beta gamma in the table. It means that alpha is written in the current shell, beta provides the dynamicity of the head, that is a movement of the head towards left or right, and y denotes the next state. Y that is a lambda, gamma, that is a gamma denotes the next state into which the Turing machine enters, right? So Turing machine enters, that is, so A replaced with alpha, and B gives to the left and right, and the gamma tells about the next state of the Turing machine. Example, the Turing machine with a 5 state Q1, Turing 5 state is a Q1, Q2, Q3, Q4, Q5. The 5 states are involved. For example, for this specified problem, where Q1 is the initial state and Q5 is the final state. So the symbols 0, 1, B is going to be considered here. So here we have a the transition table to represent the Turing machine. That is B, 0, 1 is the inputs, and the present states are enlisted in the row wise, that is Q1 to Q5. So the tape symbols are B, 0, 1, the column wise, and row wise are the states. So this example narrate about the Q1 after consuming the input symbol B, replace that is a 1, and head will be moved to the left side, and q2 state. In this case 0 and will be 0 will be replaced 0, and then towards the right side it next state q1. And when you are q2, then blank will be considered, blank will be there, and move towards the right side, and q3 will be the next state. Similarly 0 comma 0 lq, that is a move towards the left side and remain in the same state. So similarly 1 will be there, it 1 will remain and move towards the left side, that is a q2. And next q3 we have blank or q4, so move towards the right side with the next state q or q4. Similarly b or q5, that is a blank will be remain there, move towards the right side and go to the next state q5. Q4 when you consider the blank b, that going to be changed with the 0, then right side reaches the q5 final state, 0 comma 0 or q4. So 1 or q4, that is when the input is there, move towards the left side, and finally it reaches the q5, that is a terminating or halting stage, that is a 0 l q2, that to go to the q2 back, that is that can be tell with this symbol called left side, turn towards the left side. So that is one narration by this example, so that further elaboration can be considered, that is so tape and current state of the input string, the tape for the input string 00b. So we can have that we get the following sequence, that is a qt, that is 00 br o 0 qt o br 00 qbr, and q4 that is 00r, and again bb, that is a 10 q40r, that is a triple b 100 q4 br, that is a double b, that is 100 q, yes, that is a final state br. So finally we can have triple b 100 q q2 00, right, r. So bb, that is a 10 q2 000r. So bb1 q2 that is a 40r. So finally bb q21, that is a 40r. So at the end, that is a bbq, right, that is q2, bb q2 b1 40r. So and 3b q3 100r. So finally reaches the q5, that is the final state. So bb and 00, that is a bb and q5 000. So that is going to be 00b, started with that input string, and going to be recognized this string. So again, that is the stable symbol, the transition table, which we discussed in the previous slide. It's going to be witnessed here further. So from this we are able to understand the representation of Turing machine, deterministic Turing machine model, and we can represent through the different mechanism called instance description, transition diagram, and transition table. So with help of these concepts, so we are moving forward to discuss in the next session these concepts borrowed by the reference textbook called Ilan Rich Automata, Computability, Complexity, edition Pearson, and Misra Chandrasekharan, third edition, Theory of Computer by Pentisal of India. Of course, the other reference books are there: Hopcroft, Motwani, Ullman, and Introduction to Automatic Theory Language, that is Pearson Education. The other Michael Sipser book from the Cengage Learning Publication, Introduction to Theory of Computation, and also John Martin, Introduction to Language and the Theory of Computation by Tata McGraw publications, which are available, and also the other magazines and internet is also available to refer the more depth information continuation of this. So thank you for patient hearing. Thank you once again.